of engineering graphics. Here we are going to concentrate on procedure of how to solve problem on oblique line, that is projection of oblique line. So first we will go through with the basic content of projection of oblique line. So here we have the total parameters as angles and the lengths. So first is theta, phi, alpha and beta. So what is theta? Theta is the angle made by true length of line with HP, whereas phi is the angle made by again true length of line with VP. Next, apparent angles, they are like alpha and beta. So alpha is the angle made by front view or elevation length. Beta is the angle made by top view or the plan length. So always finding out the correct given data from the problem is very important. So that's why first we are focusing on the nomenclature, or you can say the parameters of oblique lines. So first, this is theta, angle made by true length with HP. Second, phi, angle made by true length with VP. Alpha and beta, they are apparent angles, that is angle made by apparent length, that is EL and PL. Front view as elevation length, top view as plan length. So what is true length? True length is actual length of line. Now this is a very basic problem of projection of oblique line. So let's say what is the oblique line? Line inclined to both reference plane, that is HP as well as VP. So that we say that's oblique line. So I have drawn one simple problem of oblique line, that is this front view, top view. So I'll explain this problem with your demonstration. So first question, as given data, true length phi, that is angle made by line with VP, theta, angle made by line with HP. A dash is the distance of point above HP. A is the distance of point from VP, that is in front of VP. So this 5 parameters as first basic problem, I'll explain. It looks like the same. So every problem will try to relate with this first basic problem. So first question. So we have total 5 parameters. True length, that is 75, A dash 15 mm, A is 0. So what it means? A is 0. Point A is in VP. That means a distance of point A from VP is 0. So it is on XY. So I will solve the first problem. So draw XY line. Draw XY line. Then locate the position of point A. So that is A dash is 15 mm. Point A, it is on XY because it is in VP. Then I know true angles, that is theta and phi. So I will mark theta in the front view, that is theta, corresponding angles as 30 degree. Same I can mark phi, that is this angle phi is equals to 35 degree. So A dash 15, A on XY, because distance from VP is 0 mm, and it is in VP. I know the theta is 30 degree, I know phi is 35 degree. So the given parameter is the true length and the true angle. So very basic first simple problem which I have drawn here also. So I will mark the true length because corresponding angles are true angles. So let us say the true length is 75. I will take 75 mm distance in compass, mark from A dash and A on corresponding lines. So this point I'll get, draw the locus from this point. So this point is B1 dash. This point I'm saying B2. Now I know 5 parameters. I just plotted this A dash, A, theta, phi and the true length. So that is complete given data. So now I need to find out apparent length and apparent angles. So how can I find out this? So I'll just project this B1 dash onto the locus of A and then rotate it on the locus of B. I will get this point as point B. Join this is plan length and this angle made by this PL is called as beta. Similarly, I know true length point in the top view as B2. Project this point B2 onto the locus of A dash, and A dash as a center and this as a radius. Mark the another arc. Again, you need to rotate this, so you'll get this point as B dash. Join this. This is elevation length, corresponding angle this as alpha. So this is whole problem. I was knowing two parameter A dash A, then I was knowing this parameter as theta 30, phi 35. Then I got the locus at B1 dash and B2. Then how we get point B and B dash? Just by projecting true length and taking this A as a center, this distance as radius, rotate it, you'll get point B. Then you can draw this projector. This is projector of B, projector of A. So this is, I can say, as projector distance. Projector of A, projector of B. There always B dash and B lies on the same line. So this is PD. This is whole problem. Once again I will just summarize. I was knowing 5 parameters: A dash 15, A on XY. I was knowing true length, theta and phi. So first I plot A dash 15 above XY 15 mm. Then A on XY, because from VP distance is 0. Right? Then I marked corresponding angles at A as theta, at A as phi. Mark the true length because theta, pi, these are the angles made by true length of line. So I got B1 dash and B2, true length points in B1 dash in front view, B2 in the top view. Then how to get this plan length as top view or elevation length in front view? So to get point B, I projected B1 dash onto the locus of A, then A as a center, rotate this, you will get the point B. Then similar way, project this point B2 onto the locus of A dash and again rotate onto the locus of B. You will get this point as a B1 B dash and this corresponding length as EL. Same problem I have drawn here. A dash and A. This is a generalized problem sentence. A is above HP and A is in front of VP. So let's say 10, 20 mm or randomly I have taken the values. So A dash is above HP, point A is in front of VP. So I have located A dash A. Let's say then I know this as a true length, theta. Theta is angle made by true length of line, that point is B1 dash. Phi is again true length angle in top view, that point is B2, I am calling it B2. This point B dash as a projector, so B dash B. This is projector distance between the 2 points. EL and PL, how we get EL, PL? Project B1 dash onto the locus of A. So from this I have drawn one projector or perpendicular. Then rotate onto the locus of B. So that is your PL, angle is beta. So that is complete top view. Same for EL. Project B2 as a perpendicular onto the locus of A dash. Again rotate, you will get point B dash and length is EL. So complete front view. For HTVT, extend EL on XY. So I am extending this EL on XY. This point is H dash. Drop a projector from this H dash onto the extended, this is extended PL. So this point is H. This is small, very small length as HT. Same for VT. Extend this PL on XY. This point is V. And from this, drop a projector again or perpendicular onto the extended EL. This point as V dash. Or I can say this distance as VT. So this is HT, this is VT. So now every problem will try to relate with the first basic thing of first problem TL theta phi. So got it? So that's very simple. When I was knowing 5 parameter as TL, theta, phi, A dash and A. So first I need to plot 5 parameter A dash and A. I have marked here true length and corresponding angles. I got the point B1 dash and B2. Then I got point B and B dash by projecting true length point and rotating on the corresponding locus. And corresponding angles are alpha and beta. So now we'll see question number 2. So once again I will revise. Parameters are theta, phi, alpha, beta, true length angles with HP, with VP, angle made by front view, apparent angle, beta is again apparent angle made by top view, we may call as plan length. What we do in this as construction or a procedure, we always rotate EL or PL from its corresponding locus, means from B dash to A dash locus, same from B to A or A to B. So from B1 dash take a projector and rotate, from B2 take a projector and rotate, so you'll get corresponding points. So we always rotate EL and PL and we always project corresponding point B2 and B1 dash as true length points. So now question number 2, given is A dash 15, A0, B dash 53 and B45. So it is very simple. Point A is in VP whereas point A is 15 mm above HP. So A above HP in VP. Same point B is 53 mm above HP, it is dashed. So I am saying that locus of B dash, locus of B, locus of A and locus of A, corresponding front and top view. And the true length is given. So again very simple problem. I will draw first XY line and mark all the locus. So I know point A dash. Mark A dash at 15 millimeters above XY, that is above HP. Point A, it is distance 0, means it is on XY. So I can say this is the locus of point A in front view. And this XY line as locus of point A in top view. Similarly mark locus of point B from XY. So above HP 53 mm. So from XY I need to mark 53 mm line. Remember this distance from XY is 53 mm. Okay. Same point B is 45 mm, that is from VP 45. So I will take from XY this locus as locus of point B in top view. Last parameter, so I was knowing 5 parameters: A dash locus, A locus, B dash locus and B, and last one is the true length. So very simple. I know A dash, I know A absolutely on one projector. Mark true length from A dash in front view. So true length is 75 mm. I will take 75 distance in compass. From A dash I will mark the arc on this locus, which is I can say locus of point B in front view. I know the locus of B, I know true length, I know A dash, so I can mark the true length. Join it. This point is B1 dash. Same, I know this locus also, mark the true length. Join it. This point is B2. The length is true length. So both are true length because we know the locus of B point in front as well as top view. Then simple problem, once again I know true length because I know B1 dash and B2 locus. Now what I will do, I will take a projector from B1 dash onto the locus of A, and then A as center, this distance as radius, mark the R. This point will be point B. Simply join it. This is PL. Same, you can do projectors of point B and again rotate, otherwise just draw a projector. So I'm just using simple concept of projector. Once you get any point as a B or B dash, draw the projector. So from this I'm going to draw projector, this point as B dash and join it. This is your elevation length. So problem completed. So just mention the angles. This angle is theta, this angle is alpha, this true length angle in top view is phi, and this angle is beta. So again, quick recap of this problem. I was knowing 5 parameter A dash A, B dash B, means 4 locus and the true length. So simply I plotted 4 locus A dash above xy, A point on xy, B dash locus and B locus. So I know all 4 locus and true length. From this A dash and A, I have to mark true length. So I can just mark this true length 75 mm. I will get point B1 dash and B2. So once I know B1 dash, take a projector onto the locus of A and rotate. You will get the point B. Once you know any point B dash or B, just take a perpendicular, you will get point B dash. So from this B, I have drawn one simple projector, I got point B dash. Join the lines, you will get EL, angles alpha. The corresponding top view length is PL, angle is beta. So that's problem done. Okay, now question number 3. What is given in this? A dash is 15, A is 0, means simply a point A of line AB is 15 mm above HP, whereas point A, same point, it is in VP. B dash, same, all given data, first 4 parameters are common, means A dash 15, A 0, B dash 53, B 45. Last parameter is changed as projector distance. So what is the procedure to solve this problem? So again same, mark A dash at 15 mm, A point on XY. Similarly you can mark the locus. So up to this it is common like previous problem. In previous problem, question number 2, I was knowing true length from A dash and A onto the locus of this B. This is the locus of point B in front view, and this is the locus of point B. So previous problem is same up to this 4th parameter. Last parameter was true length, and in this problem, question number 3, it is projector distance. So A dash A and the locus of B point in front and top view, I know this is 53 and this is 45. So again same, projector distance concept means projector of A and projector of B. So if I relate with this is the projector of A and projector of B. So this distance between the projector of A and B as projector distance is given, which is 50 mm. So what I will do, I will just take 50 mm distance on this line on XY. I will draw a line passing through this point. That means simply a projector parallel to the projector of this A at 50 mm. So parallel to this line, I will draw a projector distance 50 mm. Wherever this projected distance line cut the locus of B in front and top view, I will get the point B dash and B. Can you see that this projector line cuts the locus at B dash and B? This is A dash A. So simply I know this B dash B. Just join it. Now this is apparent length, that is elevation length, and this is plan length. Then how to find out true length for this problem? Again same concept with this previous problem. I know elevation length, so what I will do, how to get this point as a true length or this point? What I will do, I will just rotate this EL reverse, right, on A dash locus up to A dash. So I will rotate this EL, or simply I can say I will make this EL parallel to XY. So rotate the EL or make it parallel to XY and then again project onto the locus. You will get point B2. So A dash as a center, A dash B dash or EL as radius, rotate this, means making parallel to XY. I got this point, and from this take a projector, means perpendicular. This point is true length point B2. Join it. This is true length. Corresponding angles phi. This is beta. Once I know true length remains same in all the views. So I will just take this true length in compass A to B2 distance, and I will mark from A dash on this line. This point is B1 dash. So this angle is true angle theta. This angle is alpha. So problem done. Now next question, question number 4. In question number 4, what is given? A dash 20, A 20. That means a point A is 20 mm above HP and 20 mm in front of VP. Or it may be sentence point A is 20 mm from both reference planes. That simply means point A is 20 mm above HP and 20 mm from VP. Next, beta is 40. Beta is 40 degree means top view is inclined to VP at an angle, or top view makes an angle, or plan length makes an angle. Whatever may be the sentence, angle given is beta. So that is beta 40 degree, same alpha. Front view makes angle 45 degree, or elevation length makes an angle 45 degree, that is angle alpha. And the last one is projected distance is 50 millimeter. So again same, I will plot all the given phi parameter first. A dash is 20 mm, so I will draw, I'll fix this in as A dash, take a projector of A, 20 mm A below XY. So these are corresponding points, that is locus of point A in front view. This is the locus of point A in top view. So I plotted A dash A 20 mm above and below. Next is I know apparent angles in front and top view. So I will mark alpha angle at point A, which is given as 45 degree, because this is angle made by front view. So I need to draw here. Then beta angle is given as 40 degree. 40 degree. Last, very important. Now I was knowing A dash A, I plotted, I know apparent angles alpha in front view, beta in top view. projector distance is given. So same again like previous problem, I know the projector of B and projector of A. So same, parallel to projector of A or perpendicular to XY, I will draw one projector line at a distance of 50. So let's say from this XY, I will mark projector distance as 50 mm. Let us say this is the point, and from this point I will draw one projector. So this is a projector of point B. Extend this alpha line and beta line. This point, wherever this projector line cuts alpha as well as beta, we get corresponding point as B in top view, B dash in front view. Now again same problem. Now once you get the locus, how to get true length? Rotate this elevation length, because alpha is the angle made by front view, so corresponding length EL. Beta is the angle made by plan length, so it is PL. So how to get true length in any view? Rotate this. So I will rotate this EL, A dash as the center and this distance as radius. Rotate up to the A dash and then take a projectors. This point is B2. Join with A, you will get this as a true length and corresponding this angle as phi. So once you get true length in any view, true length remains same. Measure this true length, take in compass from A dash, mark here and join it. This will be point B1 dash and this angle is theta. So that's problem done. Next is question number 5. So what is given in question number? Read it very carefully. It is given that point A is, it is simply a point A is 20 mm above HP. So above HP is given, so I can say this as A dash 20 mm. Next, very important, B is 20 and B dash is 16. So there is set as condition point B is 20 mm from VP. So I can say this B is 20, that means below XY I need to mark B, locus 20 mm, and the same point B is 60 mm above HP. So that is B dash locus 60 mm. Now front view is inclined or elevation makes angle. Front view makes angle 45 degree, that is alpha. That is given, and this is phi, means angle. True angle in the top view means line is inclined to VP at angle 36 degree. So whenever the sentence is line is inclined to, so that simply means it is a true angle because it indicates the true length. So line is inclined to, here it is VP at 36 degree. So the corresponding VP angle as phi. So phi given parameter I need to find out from this. You should identify. So these are 5 parameters. So how to solve this? Question number 5. I will plot all the given data on board first. So let's say draw XY line. A dash 20 mm. Draw locus of A. But now I don't know the locus of point A from VP. So what I know, point B is 20 mm from VP. Means below XY I should mark the locus of point B. So remember, very important thing now, this is a locus of point A in front view, so that is A dash. This is not locus of point A from VP, it is the locus of point B. Very important. It is locus of point B in top view. Point B 60 mm above HP. From XY I will mark 60 mm locus line. So this is the locus of point B in front view. Remember, distance should be from XY because it is above. So this distance above XY as 60 because locus of B is given. From A dash, I need to mark if it is given any parameter. So remember, see, what is given in front view? That is alpha. So point A dash, at A dash I can mark alpha angle. So this angle is alpha. So A dash, I know locus. So from A dash I will mark alpha. Wherever it cuts, this point should be B dash. Next, phi. But to mark phi, I should know something locus of or exact point of B. So what I will do, I know now B dash, I know the locus on point B. So what I will do, I will take a projector from point B dash, because concept is B dash and B, they always along the same line, that is on the projector line. So I will draw the projector from B dash, and we know the locus of B is this line, that is 20 mm from XY. So this is locus of B, this is the projector of B. So this is point B. Now angle is given, that is angle in top view, angle made by line in VP. So how to get true length? Remember this phi is the angle made by true length of line, and this point what we get here, it is a B. So from this, if you want to get a point, we should have which parameter? Either plan length or angle beta. Then how you are going to draw this problem? What I know this as EL, right? Elevation length. So now how to get true length once you know elevation? See this problem. This is elevation length. I am going to rotate this EL onto the locus of A dash and then project onto the locus of B. Same I am going to do here. Make elevation length parallel to XY or rotate it, and from this take a projector onto the locus of B. So that's the point B2, this point. Now you can mark the true angle as phi. So here you can take the angle this as phi, because you know now true point as B2. Now draw the projector of A. Wherever it cuts this phi line, this is the point A, and draw the locus. So you get the locus as locus of point A in top view. Join this will be your corresponding PR. Take this true length, mark here, this will be point B1 dash and corresponding angles theta. So this is your true length and this is plan length. So problem done. Now next, question number 6. What is given? Point A dash is 0 means point A is in HP. A is 15 mm, that means point A is 15 mm from VP. EL, PL and TL, that means elevation length or front view measures 65 mm. Top view measures 70 mm, that means plan length. And the length of the line is 90 mm, that is true length. So next, question number 6. Point A dash, it is on XY. So A dash on XY. Point A is 15 mm from VP. So below XY 15 mm. This is the locus of point A in top view. And this XY as this is a locus of point A in front view. Now I know A dash A, but I don't know any angles theta, phi, alpha, beta. But I know three lengths as elevation length, plan length and true length. Now see this problem. This is elevation length, this is plan length and these are the two true lengths. So whenever I know these three parameters as EL, PL and TL, how we will get the locus in front and top view. So elevation length, how we get this point? Suppose I want this B dash. This EL I need to make it parallel on or to the XY. So I will make this EL parallel to XY, and on this length is true length. That means this EL is, when it is parallel to XY onto the EL line, if I extend this EL in top view, we'll get point B2 when we know the true length or true angle as phi. So if you know true length or angle phi in top view, you can easily get point B2. How? Just make EL parallel to XY and project EL line. On that line, you mark the true length or phi. You will get point B2. Same for B1 dash. When you know PL, make PL parallel to XY. That means reverse this case. This is parallel. This is also PL because length remains same. So this PL, when I project PL in the front view, this line, on this angle is theta or the length is true length. So now with the same concept, I know EL, PL. So what I will do, I will mark EL here. So the EL length is given as 65 mm as EL, and PL is a 70 mm. So let's say I'll mark PL here. PL as 70. 70, that's this point. So what I need to do, I need to take projector from EL point, let's say 65 from front view. So let's say this is EL. See this? So from this I can take EL projector and mark the true length. So this is 65 as the length of EL. Onto this line as EL projected, I need to mark true length because I know true length. So from A I will mark true length, and this point is B2. Join it or get the locus. Same. This is plan length PL. So project this PL line in front view and from A dash mark the true length. This point is B1 dash. Draw the locus and join it. So that's the problem done. Whenever you get any locus by construction, it's very simple to get or to draw whole problem. So I was knowing PL, I projected PL in the top view, mark the true length. Even if you don't know true length, if you know angle phi, you can get the same locus. Same here, if you know this PL, project the PL in front view, you can mark either true length or true angle as theta. In this problem they have given true length as 90 mm. So I will mark this as true length in both the view. Now simple, I know ELPL. Either you can rotate corresponding ELPL, you will get the same point, or you can mark directly there here as elevation length, this point as B dash. Take a projectors, this will be B. Just join it, or automatically this will be your plan length. So whole problem done. Okay, now question number 7. Point A 20 mm above, 65 mm from VP. Point B is 20 mm from VP. Top view makes angle 40 degree with VP, and this is theta, means line is inclined to HP. So line is inclined to HP, that is theta, and top view makes or plan makes angle, that is beta. So 4 parameter, last one is theta as 5th parameter. I will mark on the paper. So first A dash 20 mm, mark 20 mm locus. Now A is 65 mm. So from XY I will draw 65 mm locus. So remember, this is locus of point A in top view. This is locus of point A in front view. Very important, I have marked this two. Third one is point B from VP, which is 20 mm. So where it is? Below XY 20 mm. So this is the locus of point B in top view. And beta is absolutely with VP angle, that is top view. Theta is angle made by line with HP. So first A dash, locus A, and the third one is B. And I know last two angles. So what I can do, this point is A, this is A dash. So I can mark beta angle here, right? This is locus of B. So this point will be absolutely point B. This angle is beta as 40 degree. Next angle is true angle, which is HP. So what I will do, I will mark the true length angle as theta is equals to 34 degree. Clear? So I have marked A dash 20 mm above, A 65, B 20 mm below XY because it is from VP. Beta is apparent angle in top view, and theta is angle made by the line with HP. So first I mark A dash, then A 65, then I mark theta as 34 degree. Beta is angle made by top view, so I mark beta 40 degree. I know the locus, I got this point. Then see how to get true length, or how to get, see, we don't know this true length in this. So how to get locus in the front view? By construction. So see here, I know this point B with the corresponding angle. So how will get the corresponding point in the front view? First, what I can draw, how to get locus? First I can draw this locus or instead of, sorry, not locus, it is projector. So draw the projector of B. Second, this is plan length, so make this PL parallel to XY and project. So this is the way to get locus in the front view. I know this AB as PL, make this PL parallel to XY means rotate this PL, this point you will get on locus of A or B, and project this line vertical, and on this line you need to have which angle? Theta or true length. So I know theta right now. So what I will do, I need to make this PL parallel. So this AB as PL I need to make parallel to XY. So what I will do, A as a center, AB as radius, this PL I will make it parallel to XY. So onto the locus of A, and then take a projector of this point, project in the front view. So make it PL parallel and project on theta line. This point will be B1 dash and draw the locus. Right? Now this is true length. Measure this true length, mark from this A onto the locus of B. This point will be B2, angle will be phi. You know this B point, draw the projector of this B, this point as B dash. Draw this line, this is true line and this is elevation length, and this corresponding angle made by elevation length is alpha. So that's whole problem. Next question is question number 8. In question number 8, P dash is 25 mm, P is 100 mm, Q dash is 70, alpha 40 and beta 50 degree. So the sentence is like, point P is 25 mm above HP and 100 mm from VP. Point Q is 70 mm above HP. Front view and the top view makes an angle 40 and 50 degree respectively, or it may be the last sentence for this as elevation makes this angle and plan make this angle, that is alpha and beta. So I am going to solve this problem by just plotting given data. So draw first XY, mark P dash 25 mm above and P at 100 mm below XY. So this is the locus of point P in front view, whereas this is the locus of point P in top view. So just by drawing a projector, I will get this 2 points as P dash and this as P. So I know P dash and P. Next is Q dash as 70 mm. So from XY 70 mm distance, I will draw the locus of point Q. That is locus of point Q in front view. So that is 70 mm. Next, I know alpha and beta, these two angles. I know point P dash, I know Q locus, so I will mark here angle, that is alpha. So this point will be point Q dash, because angle is apparent angle, corresponding length is elevation length. Next, I know angle beta. I know angle beta, I know point dash, so I will mark, suppose like this. You can take this beta like this also, because the locus of point Q from VP is not mentioned, so both the solutions are correct. Let's say I will take this as beta angle as 50 degree. So on this, I know Q dash locus, I will drop a projector and this point will be point Q. Draw the locus. Say I was knowing P dash 20, I was knowing P 100, so I drawn the two locus. Q at 70 mm, so from XY 70 mm. I was knowing angle alpha, so I marked alpha, I got the point Q dash. At point P I marked beta like this. Just drawing a projector, I will get point Q. So once you know EL, this is the plan length as top view. So how to get the true length? So that's whole problem now. Last, how we get true length? Once we know EL or PL, making this EL parallel to XY. So I will rotate this and then taking a projector onto the corresponding locus of Q. This is what we got the locus of point Q in top view. So just by projecting this point, that means by rotating or making parallel EL to XY and then onto the locus of Q. Join it. This is the true length and this angle is angle phi. So that's whole problem.